Hey there, Emmanuel here from WebDevFuel, and in this video we're going to continue with the theme of the previous one of building a data dashboard using HTMX and Go. In the previous video we went over how to add a live notification feed to a web application using HTMX, Go and WebSockets, and if you want to see that video I'm going to leave a link in the description down below so you can take a look at it. And during this one we'll focus on something different, and that is a data table. We want to, by the end of the video, have a data table that we can use to not only see information about our users, but also be able to interact with the data table by sorting it, filtering it, and also have the ability to have pagination to move between different pages. And to accomplish this, instead of going the quote-unquote normal route of using a PostgreSQL database, we want to do something a bit different because we want to ensure that the web application is a bit more performant. So if we were to choose PostgreSQL and do the querying that way, then it would maybe be okay if we insert a certain number of resources inside of the database. But when the database starts to grow and we want to do stuff like, let's say, filter by different stuff, so filter the user by the status, in this case that is what we are going to do, or if we want to sort it, or even later if we want to search something inside our list of users, so let's say that we want to search by a specific email address. In those cases PostgreSQL starts to show its weakness and it is better to use something different. In this case we are going to choose Meilisearch, which is an alternative to Elasticsearch, and it is a great tool. It is built with Rust and it will again allow us to insert inside an index different documents, in this case our users, and then be able to query those documents in a very performant way. The first thing we want to do is install Meilisearch locally. Now later, if we decide to take this web application to production, then the setup is going to be different than this one, but this local installation is perfect for working with Meilisearch in development and testing everything out. As you can see here inside the documentation, it says that we can either choose to install this using the curl command and then this shell script, and then after that we can launch Meilisearch by using here this executable, or we can use different options. For example, if you are using macOS, which is my case, you can use brew to install it. You can also choose to use Docker to install Meilisearch, and finally if you're using Linux, and in this case Ubuntu, you can use the apt package manager to install Meilisearch. So first of all, make sure that you install it, and then let's continue. And actually, before I forget, if you want to access the source code of this entire video and see what the final result is, I'm going to leave a link in the description down below to the GitHub repo so you can take a look at it. With this being said, after installing Meilisearch inside the terminal, we can simply run here the Meilisearch executable, and after doing this, we are going to get this thing here printed to the console. One thing again to keep in mind is that when we move this web application to production, the setup is going to be different. In this case, it says that no master key was found. The server will accept unidentified request, so you can think of this as an unauthenticated request, and that the master key of at least 16 bytes will be required when switching to a production environment. But again, now for development, this is perfect. For us, this is a good setup to use this with our Go and HTMX web application. Now, the next thing that we want to do is we want to install the Go client to be able to interact with Meilisearch. So let's move back here to the browser, and we want to search here for Meilisearch and then Go. And the first result, as you can see here, is a Golang wrapper for the Meilisearch API. Let's just zoom in this a little bit. And the cool thing about this is that the Meilisearch Go client is a first-party client. So it is developed by the Meilisearch team itself. So as you can see, it is part of the organization. And then the package name here, or the repo name, is Meilisearch-Go. So let's take a look here now at the part of the installation. So we have this installation section, and to install it we can copy this command, and then inside the root of our project, and again you can take a look at this project in the description down below. You can access the GitHub repo and see everything that we're doing here. Inside the root of the project we want to paste here the command, and after we run this is going to install Meilisearch. In this case I already have installed this previously, so this is simply going to upgrade, but after running this command you are going to have Meilisearch available as a client with Go. The next thing we want to do is have a way to actually initialize the connection to the Meilisearch client, and to help us avoid having too much logic inside the main.go file, we are going to abstract that away into a package. So let's take here a look at the root of our project, and here we want to create first of all a new directory that we'll call search, and then inside that directory a file that we'll call search.go. So let's create both the directory and the file, and inside this file we want to add the following stuff. First, we need to specify the package name, which is search, and then we want to ensure that we are importing the Meilisearch Go client. After doing this, we specify here a function to initialize a new Meilisearch client, and this is going to return the Meilisearch.serviceManager, so this is the type that this function returns. And to return this, we simply say here return Meilisearch.new, and the argument that we need to pass here is the Meilisearch host, and we are going to extract this from the environment variable. So in other words, this is essentially the URL that we want to use to be able to hit the Meilisearch endpoints, the Meilisearch API, and interact with it. Now let's take a look at how we can set this Meilisearch host. So if we navigate back to this pane, as you'll be able to see, it prints here what the host is, and in this case the server is listening on HTTP localhost, and then the port is 7700. So let's copy this, and then we want to stop here our server from running, and we want to say here export Meilisearch and then underscore host, and this equals this URL that we've copied. And now let's start the host, the program again, and if we now navigate back here, this is all going to work correctly. Now let's initialize the Meilisearch client inside the main.go file. So let's navigate here, and after initializing the connection to the database, we want to say here Meilisearch client and then colon equals. We want to import here the search package that we've created, and we want to call the new Meilisearch client function. And now the next thing we want to do is we want to pass this into the handler so that our handlers, when we run HTTP requests, have access to this client. So let's take a look here at the new handler function. And now we also want to add here the Meilisearch client. So let's say here Meilisearch client, and this is going to be Meilisearch.serviceManager. So if we take a look really quickly here, this is the type that this is again going to return. This is a service manager, and we want to also pass the exact same thing here. So Meilisearch client, and this is Meilisearch.serviceManager. And finally, let's also add here a comma, and we finally want to pass this here when we return the handler. If we now navigate back to the main.go file, as you can see, we need to pass here an additional argument, and that is going to be the client that we've initialized. And now inside each one of our handlers, we are going to have access to the Meilisearch client. So let's take a look, for example, here at the user handler. If we say here h dot, we are going to have here access to the Meilisearch client and all of its methods. So for example, if we want to grab here an index, we can do so, and we can use all of the methods that again allow us to interact with the Meilisearch API. But before we continue, if you want to learn more about how to build web applications with HTMX, Go, and PostgreSQL, then go to webdevfuel.com/HGSB or click the link in the description down below. Now, the next thing we want to take a look at is our handlers. So in this case, the users table is going to work in the following way. Instead of having the initial rendering of the page occur and then rendering the table right away, we want to sort of only render an initial skeleton. And then when we do that initial rendering, we want to show a loading spinner. And then after we show that loading spinner, we are going to use HTMX to take care of that request that is going to be sent to the backend. And then the backend is only going to return a partial with the table. And also when we refresh that table, so let's say that we change the sorting of the table or the filtering, or we go to the next or the previous page, in those cases we also want to show again the loading spinner and only then render the table after it finishes rendering, or in other words, after it comes back from the server. So because of this, we will not only later be splitting this into two different templates, so the initial rendering of the page and then the users table template, but we also want to split this into two different handlers and routes. So first of all, let's take a look at the simpler route that is going to allow us to do the initial rendering of the page. So as you can see, this is pretty simple. The name of the function is users handler, and it takes as an argument the usual stuff when it comes to HTTP requests, so a response writer and the pointer to the request. And then we simply want to call the users template from the view package, and after doing this, we want to render it. Now at the moment, since we haven't yet gotten to the part where we actually implement the templates, we still get here an error since we still don't have that template implemented, but when we get to that part, these errors are going to disappear. But keep in mind, this is simply going to do the initial rendering with the entire page, the skeleton, the sidebar, and all of those kinds of things, and then it is simply going to have a loading spinner and also all of the logic for HTMX to actually do the request on the initial load and when stuff about the table changes. Now let's take a look at the users table handler that is going to return again only a small portion of HTML that is going to be inserted into the DOM using HTMX. So also here we pass the response writer and the pointer to the request. And the first thing we want to do inside this handler is grab all of the information from the URL query. So we are going to send essentially the data that we want to fetch from Meilisearch to the backend using the URL query. So we are going to tell the backend what we want to fetch via the URL query, and we want to first of all extract all of this information. We'll start by grabbing the sort query param from the URL, and to accomplish this we want to first grab here the pointer to the request, and we want to access here the URL, call the query method, and finally call the get method and pass as an argument the query param that we want to extract from the URL. In this case, using Go, this always returns an empty string. So even if this doesn't exist inside the URL, if this query param doesn't exist at all in the URL, it is still going to return something instead of an error, which is going to be an empty string. So we want to take that into an account, and if that's the case, we want to provide this with a default value. So if sort equals an empty string, then we want to sort this by the name in an ascending order. Next, we want to grab the filter query param to be able to filter this by different kinds of information about the user. In this case, we'll be able to filter by a different status. So if, for example, the user is active, if the user is pending, and so on and so on. In this case, we don't need to actually pass here a default value. So if this is an empty string, we are simply going to pass this empty string to Meilisearch. And finally, we want to know what page is currently being fetched, so that we know what list of users we want to return back to the browser. So first of all, we want to do the exact same thing that we did up here. In this case, we pass the page as an argument, and this is going to return a string. In case this doesn't exist in the URL, then we want to provide this with a default value. So if page string is an empty string, then we want the page to be the first one, the page number 1. But one thing to keep in mind is that since this is going to return a string and we actually need to pass into Meilisearch an integer, we need to transform this from a string to an int. And to do this, we use here the string conversion package or strconv, and then we use the atoy method to be able to transform this from a string into an integer. And we pass as an argument the string that we want to transform, and this is going to return here an integer, and it is also going to return an error in case it is not able to transform this from a string into an integer. And if that's the case, if the error is different than nil, then we simply want to return, since we are still in development, so we don't want to overcomplicate the error handling. Now we finally get to the part where we get to interact with the Meilisearch client, and in this case we want to search for documents inside an index. So if you're not familiar with Meilisearch, it sort of revolves around indexes. So we specify an index, we create an index using Meilisearch, and this sort of translates to a table inside a SQL database. And then using those indexes, we can add documents to them and then do searches inside of those indexes. So first of all, we want to grab here the user's index. And after doing this, we have the ability to do different things with this index. In this case, we want to do a search. To accomplish this, we'll be using the search with context method. The first argument that we want to pass is the context from the pointer to the request. The second argument is going to be an empty string. And finally, we want to pass the search request struct. Now, if we were to interact with this via the HTTP URL, so if we were to query this using curl, for example, we would pass here a JSON object. In this case, since we have this Meilisearch Go client, it is very nice since we have the type safety and we know the things that we can and cannot pass into Meilisearch. So we want to use again here the search request struct, and this is going to take here a few different fields. So first of all, we want to pass here the sort. So this is going to be a slice of strings. In this case, we only want to pass one value. So we pass here the string that we've grabbed from the URL query params. Then we want to do the exact same thing for the filter. So this is also a slice of strings, and we pass this here. And then we want to pass here both the page and the hits per page. Now, one thing to keep in mind is that when we transform the page string into an int, it is going to simply be an int and not an int64, and that is what this field requires. So to be able to do this transformation, we want to use this inbuilt function int64 and pass here as an argument the page, and this is going to transform this from an int to an int64, and we also want to do the exact same thing for the hits per page. The hits per page are essentially going to be the number of users that we want to be returned to us when we do this search, and I think that 25 is a good number to have for each one of the pages of our table. Then this is going to return the search response and then also an error. So we also want to check and see here if the error is different than nil, and in this case again we are going to keep the error handling simple and only return this and stop the request from continuing if we have an error occurring here. Now the next thing we want to do is we want to grab the search result hits and actually put these results into a data structure that Go understands. One thing to keep in mind is that this is going to return a slice of interfaces, and we cannot actually do anything with that when it comes to type safety. So we want to first of all grab that interface and marshal it, and after doing that we want to then try and unmarshal that back again into a data structure that we can actually understand. So first of all, we want to initialize here a slice of data.user, and if we take a look here at this struct, it is simply a struct that holds 4 different fields. First of all, the ID, the name, the email, and also the status of this user. And for each one of those, we want to add here a tag that specifies what the JSON key is going to be and also what the database key is going to be. For each one of these, we simply want to transform this from the field name into the exact same thing, but in this case all lowercase, so that it stays consistent across the JSON objects and also the database. So after doing this, after initializing here our slice of users, we are going to range through each one of the search result hits. And again, if we take a look at the type, this is going to be a slice where the type is an interface. So we first of all want to marshal this into a string, or in this case into a slice of bytes. After doing this, we want to initialize here a new data.user with this user variable, and finally we want to try and unmarshal this back again into this data structure that we actually understand and have information about. If we have any kind of error occurring here, so either here or down here, we want to simply return and stop again the request from running. And if that's not the case, we are finally going to say here that the users equals append, so that we essentially are able to append here the user that we are looping through to the slice of users. And finally, we want to grab the template and then render it. To do this, we'll be using the users table function that again is going to return back to us a template. At the moment, we still haven't implemented this, but we are going to get to that in just a second. And this is going to take three different arguments. First of all, the users, and then also information about the pagination. So we have here pagination.previous page. So this is a function that is going to return what the previous page is, and it is going to take as an argument search res.page. So based on the current page that we are currently in, we are going to extract information about the previous page link. And then we are going to do the exact same thing for the next page. In this case, we also pass as an argument the total number of pages. So let's take a look here at the pagination package. So this is going to be pretty simple. We essentially want to know if we are currently on the first page, in which case we don't have a previous button. The previous button is going to be disabled. And if we are on the last page, the next button is also going to be disabled. We have the page struct, which is the thing that both of these functions are going to return. And this is a struct that holds two different values. First of all, the value which is int64, and then disabled, which is a boolean, so that we know if the button is currently disabled or not. Again, we have the next page function that takes as an argument the page and the total number of pages. If the page is bigger or equal to the total number of pages, then we want to pass the value as 0 and it is going to be disabled. So in other words, if we are on the last page, then we don't have a next page to go to. And if that's not the case, we want to return the value as page +1 and disabled as false. And then for the previous page function, we only pass as an argument the page. And if the page equals 1, so if we are on the first page, then we want to return the value as 0 and disable also as true. And if that's not the case, return the value as page -1 and disabled as false. And then after doing this, we simply say here component.render and we pass the arguments to be able to render this using temple. But before we continue, if you want to learn more about how to build web applications with HTMX, Go, and PostgreSQL, then go to webdevfuel.com/hgsb or click the link in the description down below. Now we're finally ready to create our templates that we'll be using to again do the initial rendering of the page where we show the skeleton and then also return the partial HTML with the users table. The first one that we want to take a look at is the users template, and this one is going to do the initial rendering. So we first of all want to ensure that we wrap this around a layout, which is the base layout. And after doing this, we have this div here with the following stuff. First of all, we want to specify the ID of users. And then let's take a look here at the HTMX attributes that are going to allow us to essentially ensure that when this does the initial rendering, it is going to fetch the backend and then grab the users table. And also when we emit a refetch event, it is also going to do the exact same thing. So it is going to again show the loading spinner and then do the request to the backend and then replace that with the new table. So first we have this hx-get attribute, and the value is going to be /users-table, which is going to be the route that we'll be setting up in just a second to be able to grab the users table from the backend. We are going to use the get method to accomplish this. And then we have this hx-trigger attribute. And this essentially tells HTMX in which situations we want to trigger this request with the get method to /users-table. And these are going to be the following situations. First of all, on the initial load of the page. So when this does the initial load, after it renders this div, we want to make the request to the backend and show the table. And also when the refetch event gets emitted. Now we are going to be able to emit this using JavaScript, and we are going to have, let's say, around 10 lines of JavaScript, something very basic that is going to allow us to look at different drop-down elements, and when those elements change, when the values of those elements change, we are going to have the ability to essentially reload the entire table. And then we also have here the hx-target, and this is the target that we want to use for when the partial HTML comes back from the backend. So in this case, we don't actually want to replace this thing itself, but instead we want to replace the element where the ID is stable. And then we have this hx-include attribute, where the value is going to be .attribute. What this is going to tell HTMX is that we want to look for all of the elements inside this div that has a class of attribute, and then we want to extract the value from these elements and send those values along with the request to the back end when we do this request to /users-table. And as you can see, we have here two different select elements. We have this one for the filter and another one for the sort. And then for each one of these select elements, we have the select attribute function that is going to return a temple.attributes that we want to spread here. And by doing this, we'll be able to add here a class to both of these select elements. And if we take a look here at this, if the attribute is true, which is the case for both of these, then we want to add the following classes that also include the attribute class. And this means that HTMX is going to look at these select elements, in this case at both of these select elements, and it is going to extract the information based on the name, and it is going to send that to the back end using the URL query params. First, let's take a look at the filter select element. The default value is going to be an empty string where the label is all users. So by default, we want to show all of the users inside of the table. And then we have active, blocked, pending, and also archived. And for each one of these, we want to say here status and then equals, and finally the value that we want to filter by. In this case, it needs to be all lowercase. So for example, we have here active, which is the label, and here active all lowercase. And the reason we have this structure of status equals and then the value is because this is the structure that Meilisearch wants us to pass into the API to be able to filter the documents. Next, let's take a look at the sort select element, and here we do the exact same thing. In this case, the default value is going to be sort by name in an ascending order, and then we have, for example, sorting by email also in an ascending order, also by status, and then the exact same thing, so name, email, and then status, but in this case in a descending order. And here the structure that we need to pass is first of all the key that we want to sort by, then a colon, and finally the order that we want to sort by. Now let's take a look at the table and the spinner div elements. First we have here the table div element where the ID is table, and then we want to hide this when an HTMX request is occurring. So we say here dot and then HTMX dash request, then underscore and ampersand, and we say that when this HTMX class exists, we want to hide this using Tailwind CSS, and then we also apply this default class. So what this essentially means is that when an HTMX request is occurring, so when we have this class present in a parent element, we want to hide this. And this element is going to be empty by default, again because we are not going to show the table on the initial request. And then we have this element where the ID is spinner. By default, it is going to be hidden. And then when an HTMX request is occurring, we want the class to be blocked so that we see this inside the DOM. And to actually render the spinner, we use this SVG where the class animate spin is applied, meaning that Tailwind CSS is going to take care of spinning this visually inside of the browser. And finally, we have this table.js file that is included inside the static directory that is going to allow us to sort of sprinkle a bit of JavaScript inside this entire part of our web application to ensure that we have all of the interactivity working and also the fetching being done to the backend when we change the values of both these select elements. So let's take a look and see what's happening inside this file. We first start by getting the element by the ID, where the ID is users, and this is the element that is going to take care of making the request to the backend to then replace the part of the DOM where we want to insert the table. We then specify here a new function that we'll call dispatch refetch event, and this is simply going to create first of all here a new custom event that is called refetch, and then it is going to dispatch the event on this element that we've grabbed here. And what this is essentially going to allow us to do is not only again do the fetching to the backend to show the table on the initial load after the initial running occurs, but also be able to do the refetching on demand when we want to by simply invoking this function. Then we want to grab here the sort element. So we are also going to grab this by the ID. And this is the select element that is going to allow us to sort the table by different attributes. And then we want to add a new event listener to this element. So when it changes, we want to invoke this function and call the dispatch refetch event function so that it sends the request to the backend and then it replaces the DOM with the new table. And then we do the exact same thing for the filter element, also listen here for the change event, and when that happens, we want to dispatch the refetch event. And finally, to be able to show and hide the spinner and the table correctly when the requests are being done, we want to do the following things. First of all, we are going to grab the spinner element and the table element, and then we want to say here document.body.add event listener, and we want to listen for the HTMX colon after request event that is going to be emitted by HTMX after a request is completed. And if the event.detail.target equals the table element, or in other words, if the request that was just completed is the one that is going to replace the table, which is the thing that we are working with right now, then we want to add the hidden class to the spinner element and remove the block class, and also remove the hidden class from the table element and add the block class to it to essentially hide the spinner and then show the table after the request is done. So this is everything that we need to be able to do the initial loading of this page and also add all of the logic to be able to fetch the user's table, again, not only when the page loads initially, but also when we have either the sort attributes or the filter attributes being changed, then we want to do the refetching using our backend and then insert the response back into the DOM using HTMX. So now let's take a look at the user's table template that is going to be returned back from the backend when these requests are being done. So the template is going to take 3 different arguments like we saw inside the handler. First of all, the slice of users, and then the previous and the next pagination structs, which are pagination.page. So this is the type of both of these arguments. And then inside this template, we have here a few wrapping divs, and inside of these divs, we have the table element. We then have the table head, and we have here all of the labels for the name, the email, the status, and also this empty label which is where we are going to show the actions. And then inside the table body, we want to range through each one of the users, and for each user, we want to render a table row. This is pretty basic stuff. We essentially have here a user row where we are going to show the user name, the user email, and then we also have here some helper functions that we are going to take a look at in just a second to be able to show the status attributes and also the status label. So this is going to allow us to show the appropriate color for each one of the statuses and also the labels to essentially transform this from all lowercase into a label that we can show inside of the table. Then down here we have a link to be able to navigate to the user page to see the details about a user. It is essentially a link. And finally, at the bottom, we have our element that is going to allow us to have pagination to essentially go to the next and previous page. The ID here is pagination. And inside of this element, we have the pagination item template being used twice. We are going to take a look at in just a second at how we can create this pagination item template and how to implement all of its logic. But essentially, we want to pass here a path that is going to be /users-table. And then we want to pass here the page that we are currently working with. So the page that we essentially want to navigate to. In this case, we want to pass the previous dot value. So we want to pass here, first of all, on the left, the button that is going to allow us to navigate to the previous page. And then we also want to tell this template if this is disabled or not. Again, because in some situations, these buttons are going to be disabled. Then inside of this one, we want to render a arrow that points to the left and also show here this prev text. And then we are going to do the exact same thing for the next button. In this case, we also pass here the page number that we want to navigate to. And then we say here next.value and also next.disabled. We show here the next text and then also an SVG with an arrow pointing to the right. And finally, we want to include here this pagination.js file that is going to allow us to, again, sprinkle a bit of JavaScript into our logic to make things easier for us. Inside this file, we want to grab all of the elements using query selector all, where the selector is the ID of pagination and then button, meaning that we are going to grab both of the buttons that we have inside the div element that we wrap around both of the pagination buttons. And then inside both of these elements, we want to add a new event listener so that when a click occurs, we want to remove the hidden class from the spinner element and add the block class and do the opposite thing for the table, meaning that when we click on either the next or the previous buttons, we want to hide the table and show the spinner again to let the user know that a request is being made to the back end, and then the table is going to be replaced after that request is completed. Finally, let's take a look at the pagination item template and also the helper functions that are going to allow us to render the status attributes and also the status label. First here, the pagination item template is going to take as an argument again the URL and the disable to let us know if this is disabled or not. And if that's the case, so if disable is true, then we simply want to render a div element where the following classes are applied. So we want to add here a text neutral and sort of let the user know visually that this is disabled. And then we pass the children, in this case the icon and the label, inside this div element. And if that's not the case, if this is not disabled, we want to render a button element and we add the following classes. We also say here hx-get and then we pass the URL, and finally we pass the children here. And since this is nested inside the element where the ID is users, it means that HTMX is going to automatically allow us to inherit all of the attributes from that element, including the target and the include attributes. And this means that when we make this request using the get method and this URL, it is going to also append to this URL our filter and our sort. And it is going to, by default, also have the correct target, meaning it is going to replace the table element. And if we take a look here at the HTMX documentation, it says that the default behavior for HTMX is to quote-unquote inherit many attributes automatically. That is, an attribute such as hx-target may be placed on a parent element and all the child elements will inherit that target. So this makes it easy for us to add here a different URL inside of this element and then have HTMX inherit everything from the parent element, including again the target, which will allow us to insert this into the right place inside the DOM, and also the include HTMX attribute that is going to also allow us to send along with this request not only the page that we want to request, but also the sort and the filter attributes. Now let's take a look at the helper functions to render the status attributes and the label. First of all, we have this one that is going to take as an argument the status, and it is going to return a type of temple.attributes. First, we want to instantiate here the attributes. So we say here make, and we pass the type, and we instantiate this with the size of 0, and then we specify the base class. And then we're going to do a switch statement based on the status. And if it is active, we are going to say here that the class attribute is going to be the following one. So we are going to use the sprintf function from the format package to be able to append here, first of all, the base class and then add additional classes for the active status. Here we want to render this essentially with a blue background and also the text also blue. And then we have the blocked one where it is going to be red. Then we have the pending where it is going to be gray, and archived where it is going to be slate. And by doing this, we have the ability to have a base class and then different kinds of classes being applied to this element based on the status. And then we have this function to render the label. It is pretty simple. We pass here the status as an argument. We also do a switch statement. If it is active, we want to add the correct label and then do the exact same thing for all the other ones. Now we have everything set up when it comes to the templates. So let's navigate to the router.go file to set up our routes to be able to navigate first of all to a page that is going to allow us to do the initial rendering of the page, and we also want to add the /users-table route to be able to return only the partial HTML to render the table. So I went ahead and added here these two new routes. Both of them are going to use the get method, and here we want to use /users and invoke the users handler, and the exact same thing for the users table. We add here the path and then we invoke the users table handler. Now let's visit our web application inside the browser, and let's also ensure that we are throttling all requests using the slow 4G so that we can see the loading spinner and the table being replaced inside the DOM. We are currently inside the dashboard page, and we have this users button that is going to take us to /users. So if we click here, as you'll be able to see, we get this loading spinner by default, and after the request is completed, it is going to replace this with the table. And if we take a look at the requests that were done to the backend, as you can see, we have here this users-table. And if we inspect this request, we have here the request URL, and we pass not only the / path, but also all of the query params, including the filter, which by default is an empty string, and then also the sorting strategy, which by default is the name in an ascending order. And if we also see here the response, it is simply a div element. It is a HTML partial that is going to be used then to insert it into the DOM and show the table here inside the browser. And if we also shrink this really quickly, and if we take a look at this, by default again, we are not filtering this by any kind of status, so we have here active, archived, and so on and so on. And if we click here on, in this case, the filters, we have all of the users, which is the current one, and let's say that we only want to see the active users. So this is going to show again the loading spinner, and then it is going to show here all of the users that are currently active. And let's also see here again the requests. In this case, we have the filter where the status is active, and we then also have the sorting strategy which stays the same. And if we also try to see here the pagination, we have the previous and the next button. By default, the previous is disabled since we are on the first page. And if we click here on next, as you can see, we now get here a different set of users, but the status stays the same. It is still active because, again, it is going to inherit these properties from the parent element. So if we take a look here now at this, we still have here the filter where the status is active, and we also have here the page which is the number 2. And let's also try to now show here all of the users. It is going to go back to the first page, so we now don't have any kind of page information being sent here. And if we try to sort this instead of filtering, let's say that we want to sort in this case by name descending. So we start here at this plus sign, and if we do here the descending order, we start here at the Z letter. And we can do also the exact same thing, let's say here for the email. So we now get here this plus sign, and if we try to sort in a descending order by the email, we also get here this, and we can also combine these things. So let's say that we want to sort in a descending order by the email, where, for example, the users are blocked. We get here all of the information about our users being correctly displayed inside of our browser. And if you want to populate Meilisearch with fake data to use in development, we also have a command available to us to be able to seed the Meilisearch instance. So let's navigate here to cmd and then seed. And here we simply need to say go run dot. And this is going to not only populate a PostgreSQL database that we are currently connected to inside this web application, but it is also going to add a new users index to Meilisearch along with a new list of documents that are randomly generated. So now if we navigate back to our web application and we refresh, as you will be able to see, we now have here a different set of data. And if we do the exact same thing again, as you can see, we now have here again a new set of data. So this is it. This is everything that we need to be able to add a table to a data dashboard using Go HTMX and also a bit of JavaScript. And I think this is a great way of doing things when it comes to adding here a data dashboard that has a lot of information, because again, we have the simplicity of Go and HTMX. And when we actually need to sprinkle a bit of JavaScript inside our web application, when it makes sense, we can do so using bits of JavaScript along with our HTMX. I hope this video was helpful to you, and I'll see you on the next one.